Okay, so these are the notes for graphing quadratic inequalities. So let's go ahead and start by these filling in the blanks. It says a quadratic inequality in two variables can be written in one of the following forms, where a, b, and c are real numbers and a cannot equal 0. So you notice these are all quadratic functions in standard form. The only difference is they don't say equal to. What they all say is an inequality sign, less than, greater than, less than equal to, greater than equal to. All right, from here it says the graph of any such inequality consists of all solutions x, y of the inequality. To graph a quadratic inequality in one of the following forms, follow these steps. All right, so the first step is this. It says, graph the parabola with the equation y equals ax squared plus bx plus c. Make the parabola dashed for inequalities with less than or greater than. And solid for inequalities with less than equal to or greater than equal to. So the main difference here being that the less than and greater than do not have an equal bar, and for solid ones they do have the less than equal to, greater than equal to, which has the equal bars. Now test a point x comma y inside the parabola to determine whether the point is a solution of the inequality. So you are going to shade the region inside the parabola if the point from step 2 is a solution. Shade the region outside the parabola if it is not a solution. So that point you test, either it's going to be a solution, you shade inside. If it's not, you shade on the outside of the parabola. Okay, so right here it says graphing a quadratic inequality in two variables. So first thing I'm going to do is I'm going to graph this by finding the vertex and then using the 1, 3, 5, 7. All right, so it's already in standard form, set equal to 0. So you can always identify what a, b, and c are. So a is -1, b is -2, and c is -1. So to find the axis of symmetry is what I should do first. So x equals the opposite of b divided by 2a. So the opposite of b is 2 over 2 times a is -1. So 2 divided by 2 times -1 is -2, which is -1. So we know that x is equal to -1. That is also going to be the x value of the vertex. So to find the y value, we're going to substitute it into here, but just use an equal sign. So y equals, so we're going to take -1, so negative parentheses -1 squared minus 2 times -1 minus 1. -1 squared is 1, but that negative in front makes it negative. -2 times -1 is +2 minus 1. And then last but not least, 2 minus 1 is 1, minus 1 is 0. So my vertex is at -1, comma 0. From here, I'm going to use the 1, 3, 5, 7. Now here we know that my a value is -1, so when I write 1, 3, 5, 7, I'm going to multiply each one of those numbers by -1. So 1 times -1 is -1, 3 times -1 is -3, 5 times -1 is -5, 7 times 1 is -7. So last lesson we talked about this again. So we go right 1, -1 tells me to go down 1. From the point I just made, right 1, down 3, because it's -3, right 1, down 5. So 1, 2, 3, 4, 1, 2, 3, 4, 5. From here we go left 1, down 1, so we're just following the same pattern. Down 3, left 1, down 5. Now before I start making my line, I look at the inequality. The inequality says less than. So less than is a dashed line, so don't make a solid line, dash like I'm doing here. I did miss that point, sorry. Next, we're going to test the point that is inside of the parabola. So one point, I usually like to use 0, 0, but I'm going to use a point that's in the parabola. So -1, -1. So my test point is -1, -1. So we're going to substitute it into this equation here. And we're going to see if it's true or false. So we have y, so let's label this as xy. So y is -1 is less than -1 squared minus 2 times -1 minus 1. So -1 is less than -1 squared is 1, but the minus in front makes it -1. -2 times -1 is +2 minus 1. And then last we have -1 is less than 2 minus 1 is 1, 1 minus 1 is 0. And is -1 less than 0? The answer is yes, it is. So that means that we shade inside of the parabola. Okay. Now there's also a trick I like to use. What I do is I go to the y-intercept, which is right here, and I look at this symbol. The symbol says less than. So I shade below the y-intercept, which happens to be inside the parabola as well. If it was greater than, then I would shade above it, which would be outside. In this case, it's not. Okay. Now, how do I check my answer? You can always check it in Desmos. Okay. So I'm gonna go ahead and put this here, and we're gonna check our answer to make sure it is correct. All right. So we have y is less than -x squared minus 2x minus 1. And what we can see here is that it does match our graph. It is dashed. We have the vertex at -1, 0, and points that we should have are -1, 0, and 0, -1, which when I look at my graph will be, and we shade inside the parabola. When I move this out of the way, you see we did the exact same thing. So our solution is correct to this system of to this quadratic inequality. All right, let's go ahead and do a few more of these. All right, for this next one here, same concept. We're going to go ahead and start by finding the axis of symmetry. So x equals, let's identify A is 1, B is 2, and C is -8. So our B value is 2, so opposite of B is -2 over 2 times A, which is 1. So -2 divided by 2 is -1. So x equals -1. For my vertex, we already know the x value is -1. Now we're going to substitute this into the equation here. So we get y equals x squared is -1 squared, so in parentheses squared, plus 2 times -1 minus 8. Y equals -1 squared is 1, 2 times -1 is -2, minus 8. And then 1 minus 2 is -1, minus 8 is -9. So now we have the vertex of -1, -9. So from here we go right -1 and then down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, there we go. Just have to make sure to verify. All right, from here I'm going to use the 1, 3, 5, 7 trick here. So here's 1, 3, 5, 7. Notice that A is just 1, so that's not going to affect it in any way. So for my vertex, right 1, up 1 for +1, right 1 from that point, up 3, right 1, up 5, and then right 1, up 7. 2, 3, 4, 5, 6, 7. And then do the same on the left side. Now, if you don't like this, once again, you can always go ahead and pick points and put them in there. Now, this one is greater than or equal to, so that means my line's going to be solid. So I talked about the little thing I used where I just go to the y-intercept. If it's less than, I would shade below, which would be on the outside. If it is greater than, I shade above, which is going to be inside the parabola. So I'm going to go over here. Here's the y-intercept. It says y is greater than or equal to. So if I shade above, you notice that's inside the parabola. So I know that when I do test a point inside, that it should be inside of the parabola. Now, granted, usually the point that you want to test that's inside the parabola is going to be this point, if it's possible, is 0, 0, okay? And I only use that point, it can't be on the line, whether it's solid or dash, it can't be on the line, and I keep it right here. So I'm going to test the point 0, 0. So my test point is 0, 0. So from here, I plug it into this equation right here. So we start with, this is x, this is y, but they're both 0, 0. So 0 is greater than or equal to 0 squared plus 2 times 0 minus 8, which is 0 is greater than or equal to 0 is gone, minus 8. And 0 is greater than or equal to negative 8 is true, which means I would shade inside where this is, and you'll notice that's inside the parabola, just like we did earlier. And once again, you can definitely verify this by just typing it into the calculator. But once again, notice the work I did to get there. All right, let's take a look at example number 2. Once again, I will do this by finding the vertex. So the axis is symmetry. X equals, this is A is -1, B is +2, and C is 4. So x equals the opposite of b, so -2 divided by 2 times a, which is -1. So -2 divided by -2 is +1. So x is equal to 1. For my vertex, we now know that's 1, comma, and now we're going to plug them into this equation. So y equals negative, parentheses, 1 squared, plus 2 times 1, plus 4. 1 squared, and with the negative, so 1 squared is 1, with the minus becomes -1. 2 times 1 is 2, plus 4, and then 4 plus 2 is 6, minus 1 is 5. So I have a point at 1, and then 1, 2, 3, 4, 5. Okay, and let me just verify my work here. So opposite of b over 2a, which is 1. And then -1, 2 times 1 is 2, and 4, yeah, that looks good. All right, so once again, I'm going to use 1, 3, 5, 7. So let's just do this here. This time my a value is -1, so I multiply each one of these by -1. So -1, -3, -5, -7. And it does make sense if a is negative that it does face down. So from here, write 1 down 1, write 1 down 3, 1, 2, 3, write 1 down 5, 1, 2, 3, 4, 5. And you can go 7, but it goes off the page, so I'm just going to stop there. Left 1 down 1, the left one from that point down 3, and then down 5. And you can go 7 if you'd like. Now look over here, it says y is greater than. There is no equal bar, so we know this is going to be a dashed line. Okay. Once again, if I just want to test it, I can say go to the y-intercept. Y is greater than, which is above, and you'll notice when I shade above, that's actually outside of the parabola. And pretty much what should happen is that when I test the point inside the parabola, it's not going to be a solution. Okay, so I'm going to test the point 0, 0. So my test point is 0, 0. Okay, so from here, let's go to plug it in here. So x and y doesn't matter because they're both zeros. So 0 is greater than -0 squared plus 2 times 0 plus 4. So 0 is greater than, this is 0, and this is 4. Is 0 greater than 4? That is not true. So therefore you don't shade inside of the parabola, you shade on the outside, which happens to be where I shaded originally. So there's your solution. All right, and to verify this, once again, you can type this into Desmo to double check to make sure it does work. Now for my last one, example 2 here, it just says graphing a system of quadratic inequalities. So we're going to graph 2 systems of inequalities on here, and then the solution set is where the 2 intersect. Okay, so for the first one, I will do it in green. So we'll find the y-intercept, or sorry, the vertex. So for my axis of symmetry, x equals, there is no b value, so it's 0, divided by 2 times a is -1, which is 0 divided by -2, which is 0. So for x equals 0. For my vertex, we have 0, comma. If you plug it in here, y equals -0 squared plus 3. -0 squared is just 0, so y is equal to 3. So my vertex is at 0, 1, 2, 3. All right, we can use 1, 3, 5, 7. And that's going to be -1 times -1 times -1. And I'm multiplying it by -1 because my a value is negative. So -1, -3, -5, and -7. So write 1 down 1, write 1 down 3, 1, 2, 3, write 1 down 2, 3, 4, 5, and I'm not going to do the 7th one because that goes off the paper. And there we go. So it is dashed because there is no equal bar. And once again, you can test a point that is inside of the parabola. So in this case, if 0, 0 is available, I'm going to use that one. So here we're going to do, my test point is 0, 0. So x and y are both 0, so I'll use this one, the equation I'm using. So 0 is less than -0 squared plus 3. So is 0 less than 3, which is true. So that means I would shade inside the parabola. Now I do have a second one to do. And for my second one, once again, I'm going to have a 2 here. So axis symmetry, x equals, opposite of b is -2 divided by 2 times a, which is 1. So -2 divided by 2 is -1. For my vertex, we now know it's -1, comma, and we're going to plug it into this equation. So we have y equals -1 in parentheses squared plus 2 times -1 minus 3. So -1 squared is 1. 2 times -1 is -2 minus 3. So 1 minus 2 is -1. Minus 3 is -4. So we have our vertex at -1. And then we have 1, 2, 3, -4. Okay, so notice it's right there. And then I'm going to make my 1, 3, 5, 7. And the good thing about this one is the a value is a +1, so it's just write 1 up 1. From that point, write 1 up 1, 2, 3. Then write 1 up 1, 2, 3, 4, 5. And then same thing left side, you can reflect it. All right, this is an equal bar, so we make it solid line. And since it says greater than, if we shade above it, it should be this region right here that's inside where they intersect. But to verify this, we're going to test a point. And once again, we can test 0, 0 because that's inside of the parabola. So test point is 0, 0. So y is 0, greater than or equal to 0 squared plus 2 times 0 minus 3. So 0 is greater than or equal to 0, 0, -3. So is 0 greater than or equal to -3? The answer is yes, it is. So we shade inside the parabola, and you'll see the only parts they intersect are right here. So the solution set is going to be all of the double shaded region inside of these two parabolas, not on the dashed line, but on the solid line up into the points where they intersect with the solid and the dashed line. All right, so that concludes the notes for quadratic inequalities.